Hello. Okay, this is probably going to be quite a lengthy video all about straight line graphs. I'm going to try and get through most of the key things that you need to know about straight line graphs for kind of year 9 beginning IGCSE, GCSE kind of level. So the first thing we need to do is look at horizontal and vertical lines. So here you've got a pair of axes and I've drawn a few different lines on there. So we've got these pink horizontal lines and the blue vertical lines. We're going to look at the blue ones first. So these are going vertically across the axis and they are crossing the x-axis. Okay, each of those lines crosses and cuts into the x-axis. That means that all of those graphs would have, all of those lines, would have the same x coordinate for every point on that line. So if we just look at this one on the far right, if I just put a few points on there, and just write the coordinates next to it. So this one is 10, 7. This one, the one underneath it, is 10, 4. The point below that is 10, minus 3. And the one below that is 10, minus 9. All of the points on that line have an x coordinate of 10. That's 10. They're all 10. Okay? That means we can name this line and we can call it x equals 10. Okay, because every point on that line has an x coordinate of 10. Another way of, a quicker way of checking that is to say that it crosses the x-axis and it crosses at 10, unsurprisingly. So if we do that for the other two vertical lines, again, they're crossing the x-axis. This one, the next one along, is crossing at 4. So we would call that line x equals 4. And then the one on the far left is crossing at negative 10. So x is negative 10. So those are the vertical lines. That's how we find the equations of the vertical lines. All we're doing when we're finding an equation is giving that line a name, and the name of it describes something that is happening on that line. So in this case, all of these lines, the x coordinate is the same for every coordinate on the graph. It's either x equals 10, it's either x equals 4, or it's x equals negative 10, depending on which line we're looking at. For the horizontal lines, these are crossing the y-axis because they're going in the opposite direction. But again, we can look at the coordinates again and just have a quick look at the pattern. So if we look at these, I didn't mean to do that. These 4 points on that line. The first one on the far left is minus 9, minus 6. So this is minus 9, minus 6. The one next along on the right is minus 5, minus 6. The one next is 1, minus 6. And this one here is 3, minus 6. So this time, all of the y coordinates are the same and they are all minus 6. On that first one, I've only wrote 6, it's minus 6, isn't it? So all of the y coordinate is the same and they're all minus 6. So this line, if we were to give it a name, we would call it y equals minus 6. Now again, a quicker way is it is crossing the y-axis and it's crossing at minus 6. So that's a really quick way of naming that line straight away. The one above that then is crossing at minus 2. So that would be y equals negative 2. And then the one above that, the other pink line, is y equals 9 because it's crossing the y-axis at 9. Every coordinate on that line would have a y coordinate of 9. So we call that line y equals 9. Okay, so that's your basic horizontal and vertical lines. That is as easy as it gets. Unfortunately, it's only going to get more difficult from here. One last thing that I want to quickly go over, but I'll be honest, I kind of forgot about until right this second, are the diagonal lines that go right through the middle of the graph. I'm hoping that, yeah. Okay, give me a second to draw this one on. And then if we do a blue one going in the opposite direction, it should look something like that. Hang on, I need to adjust this one slightly. That's it. Okay. So our pink line here, if we pick a few coordinates on here so we can see what's going on, we've got, this one is 7, 7. Then we've got 2, 2. We've got -5, -5. And we've got -10, -10. So on this line, all of the x and y coordinates are always the same as each other. We've got 7, 7, 2, 2, -5, -5, -10, -10. The y and the x coordinate, or the x and the y, are the same as each other. So to name this line, we can find a way of describing that using algebra. And we say that this line is called y equals x, because whatever y is, x is the same. Now the blue line going in the opposite direction is kind of similar, just with one small difference. So if I pick this one, this one, this one, and this one, we've got -10, 10. We've got -5, 5. We've got 3 -3. And we've got 8 -8. So what's happening this time is that the x and the y coordinate are the same number. So we've got -10, 10. 10's the same number, but one of the coordinates is positive and one is negative. Obviously that switches depending on which quadrant of the graph we're in. We're looking at, this is the second quadrant and this is the fourth. So it only goes in those two quadrants of the graph. But depending on which one we're in, so in the second quadrant, the x is negative and the y is positive. When we get into the fourth quadrant, that switches around and the x is positive and the y is negative now. But they're always the same number, just with the sign switched. So this graph we call y equals -x. Now, even though in the fourth quadrant, it's the y value that's negative and the x that's positive, yeah, that's because if you end up with a double negative in one place and that makes it positive. Yeah. Basically, I've done a rubbish job of explaining that. Basically, the coordinates are the opposite sign. And it's going in the negative direction of the graph. Okay, so those are your most basic diagonal lines. We've looked at horizontal and vertical. They were either y equals for horizontal lines or x equals for vertical lines. Once we start to get a bit of gradient in this line, so we'll look at what gradient means in a minute, and we have some diagonals. These are the two most basic ones that we have. We have y equals x and we have y equals -x. They go straight through the middle of the graph. As we add more to that equation, the graph starts to look a little bit different and the equation becomes a little bit more complex. So this is what we're going to look at here. You could be asked, and I did mean to draw some tables already, to plot some graphs. Note, for most of these questions, you would be given a table of values to make that a little bit easier. I'm going to go, just -2. -1, 0, 1, 2. And these are our x values and these are our y. So we are going to draw or plot the graph y equals 2x plus 1. So again, this equation is just the name that we give to it. It's just the name that we give to the line. It is describing what's happening on the line. And again, we look into what the numbers and things mean in relation to the graph itself as we go through the video. But for now, all we need to know is y equals 2x plus 1 is the equation of the line. It's describing the line, it's naming it, and we are going to use it to be able to find some coordinates and plot the line ourselves, draw the line ourselves. We could put any values of x we wanted up here in this table. I've chosen these ones because they tend to be the most common. Like if you have it in an exam question or something, they tend to be the most common numbers that they'll use. But we could have chose any. We could have chose like -12, -6, 3 and 7. Apologies if you can hear the noise. My next door neighbours are really loud. But what we do with them is what's important. It doesn't matter what the numbers are particularly, as long as they're on the graph. It's what we then do with them to find some coordinates to be able to plot the graph ourselves. So what we're going to do is we're going to take each number in turn and we're going to substitute it into the equation we've been given. So we're going to take the x number we've got, we are going to times it by 2 because it's 2x, and then we're going to add 1. So for the first x value, we've got -2. -2 times 2 makes -4, and then -4 plus 1 is -3. You can use a calculator for this. Be careful if you're not with when you are adding on to a negative number and things like that. That tends to be most commonly, from what I've seen, that tends to be where most of the mistakes are. You can pretty much do 2 times -2. You know that's -4. But when you come to add 1 on, sometimes mistakes start to happen. So be careful with what direction you're going in when you're adding something onto a negative number. The next one then, so we're going to do the same thing except with -1. So I do -1, we're multiplying it by the 2 and then adding 1. So -1 times 2 is -2, add 1 is -1. Then we're just going to keep going. 0 times 2 is 0, plus 1 is 1. 1 times 2 is 2, plus 1 is 3. And 2 times 2 is 4, plus 1 is 5. Now we have 5 sets of coordinates, and we kind of read it this way. So -2, -3 is one coordinate, -1, -1 is the next one, 0, 1 is the one after that, 1, 3, and then 2, 5 is our last coordinate. We can plot that, we can join them up, and that will make our straight line. And we're going to extend it out because our axis is quite big as well. So -2, -3 is down here. Then we have -1, -1 is there, 0, 1, 1, 3, and 2, 5. So we can plot those points and then we can join them up like so, and then I'm just going to extend it out so it fills the whole graph. If you've got lots of room to play with on the graph, then use it, okay? Don't just join up your coordinates and stop. Extend the line out like that so that it fills the axis. But that is now the graph of y equals 2x plus 1. Lovely. Right, now we're going to repeat that and we're going to do it for 3x minus 4 and minus x plus 1. So I'm going to use the same numbers. Am I going to use the same numbers? Should I use different ones? No, we're going to use the same numbers. So our x values are -2, -1, 0, 1 and 2. And we're going to find the y values by putting these x numbers into the equation. This time we've got 3x minus 4. So we're timesing the x value by 3 and then subtracting 4 from it. So -2 times by 3 is -6. Take 4 away from that makes -10. -1 times 3 is -3. Take away 4 is -7. 0 times 3 is 0. Take 4 away from 0 is -4. 1 times 3 is 3. Take away 4 is -1. And then 2 times 3 is 6. Take away 4 is 2. And again, that gives us a set of coordinates that we can plot onto the graph. So we've got -2, -10. We've got -1, -7. 0, -4. 1, -1. And then 2, 2 is our final coordinate. I'm going to use a different colour so we can see it on the graph. So -2, -10 is all the way down here. -1, -7. 0, -4. 1, -1. 2, 2, like that. And then again, we're going to join that up and then we're going to extend the line across the graph. Trying not to mess it up as I extend it out. There we go. and then at the end as well. So that is the line y equals 3x minus 4. And then the final one, again, we're going to stick with the same values in the table. So x and y, we've got minus 2, minus 1, 0, 1, and 2. And this time we have negative x plus 1. Where we have a negative, or when we have x on its own, we've got negative x. That is the same as having negative 1x. So each time we are going to multiply our x value by negative 1, and then we're going to add 1. Okay, so the first x value we've got is negative 2. Negative 2 times negative 1 makes positive 2. Okay, because a negative times by a negative makes a positive answer. So that becomes, oh, hang on, I haven't, and then I'm going to add 1. So that becomes 3 minus 1 times minus 1 makes positive 1, plus 1 is 2. 0 times negative 1 is still 0. Anything times by 0 is 0. Add 1 is 1. 1 times negative 1 is negative 1. Add 1 makes 0. And then 2 times negative 1 is negative 2. Plus 1 is negative 1. And again, we have a bunch of coordinates we can now plot onto the graph. So we've got minus 2, 3, which is up here. We've got minus 1, 2, 0, 1, 1, 0, and 2, minus 1. So hopefully you can see there that our graph this time is going in the opposite direction to the ones that we've drawn before. So I'm just going to extend it out. I'm not going to do it the full length of the graph just because it's starting to get a bit silly, isn't it? So there we go. There is the graph. Y equals negative x plus 1. Yeah, so that one is going in the opposite direction, and we're going to look at why that happens in just a second. But that is how you plot a graph. You'd usually be given a table. If you're not, you can make your own table and put whatever numbers you want in for the x, and then use your equation to calculate the y. And then you plot the coordinates, join them up, extend the line out if you need to, and there you have it. You have a straight line graph. You've drawn one yourself. Right. So now we're going to look at this y equals mx plus c and what that means. We call that the general form of a straight line. Okay, so all straight lines look something similar to that. There's y equals and then a number, x, and then plus or minus a number at the end. To generalize that, and so it applies to any situation, we've replaced those numbers, there's something in front of x, with letters. So we've got m as the number in front of x, and we've got c as the number at the end. Okay, we're going to look at what they mean. So we've drawn 3 pink lines and 3 blue lines onto the graph, onto the axis even. And we're going to look at what is happening. So hopefully you can see that we've got these 3 pink lines, lovely pink lines, and they are all parallel to each other. The reason they are parallel to each other is because the gradient is the same. Now, gradient is how steep the line is. So the bigger the gradient, the steeper the line. Okay, the gradient on these 3 lines, these 3 pink lines, is the same, which means that they become parallel. So same gradient is parallel. Now, what we can notice is that we know they have the same gradient because they're parallel. There's also something similar about all of their equations. So we've got y equals 2x plus 11, y equals 2x, y equals 2x minus 4. All of those 3 equations have a 2 in front of the x. That 2 is telling us the gradient. So the number in front of x is the gradient of the line. So for these 3 examples, 2 is the gradient of the line, and because they're all 2, that means that they are parallel. So for the equations, the blue ones, the first line is y equals negative 3x minus 10. Then we've got y equals negative 3x, and then y equals negative 3x plus 6. This time, they're all negative 3. So that means the gradient on all 3 of those lines is negative 3. So again, they're parallel to each other. The important part is that this is a negative gradient. So negative gradients go in a different direction across the graph. So negative gradients means the line goes in this direction. Whereas a positive gradient, the first 3 lines, the pink ones, were positive. They go up in this direction. So you can tell the gradient of the line by what direction it is going on the graph. And then we can tell from the equation what the gradient is. Now, the other part of the line, so we've got 2x plus 11 up here, this first pink line, which is this one. Okay, we know the 2 is telling us the gradient. It's telling us how steep the line is. The 11 is telling us something as well, though. If we look at where the line is crossing the y-axis, it is crossing at 0, 11. It is crossing the y-axis at the coordinate 0, 11. If we look for the rest, so 2, the second line, is crossing at 0, 0. I'm going to write it next to the line so we don't get all confused on the graph. So that's 0, 11. This one is crossing at 0, 0. It's crossing right there in the middle of the graph. And then the last one here is crossing at negative 4. So 0, negative 4. Hopefully you can see that that also links to the equation. The first line is 2x plus 11. It crosses at 11. The next line is just 2x. We could write plus 0 in there if we wanted to. We just don't, because you don't need to write plus 0. But that means that the line is crossing the y-axis at 0. It's crossing at 0, 0. And then the third line is crossing at 0, negative 4, and the equation has negative 4 at the end. So that second part of the equation, the number that is added or subtracted from the x part, is telling you where the line is going to cross the y-axis. We can write that as a coordinate, 0, and then the number. So 0, 11 means that it crosses the line at 11 on the y-axis. 0, negative 4 means it crosses negative 4 on the y-axis. So then this line, negative 10, would cross at 0, negative 10, and then we can check that on the graph just to make sure. So this was the line number 1, crossing at, negative 10. Okay, so that second part of the line, that second part of the equation even, is telling you where the line is going to cross the y-axis. So let's just formalize that a little bit. So we said y equals mx plus c is the general form of the line. Whenever you have your equation written like that, m, so the number in front of x, tells you the gradient, and c, the number that is added or subtracted at from the x, tells you the y-intercept. Now, I stumbled over my words there a little bit because I nearly said it's the number at the end. It's not always. We could have an equation that's written something like this. Okay, 5 plus 2x. The y-intercept, so the m, if we colour code them, we have m and c. The m is still the number in front of x. Even though the x part of the equation is in a different place, the gradient is still the number in front of x. So the gradient there is 2, and then the c is the number that is on its own, that is added to the x part. So in this case, it's 5. Don't be put off and don't get it mixed up if they switch that around in an exam, because they quite often will, to try and trick you. Don't fall for the trick. The gradient is always the number that is attached to the x, okay? It doesn't matter if it comes at the beginning or the end, or if it's, in any place in the equation. It has to be the number attached to x. And then the y-intercept is the number that is added or subtracted to x. Okay. You could be asked to write the equation of the line when you are given a gradient and a y-intercept. So that is as simple as just putting those numbers into the general equation of the line. So if the gradient is 4, the y-intercept is at 0, -3, the gradient of that line, the equation of that line is y equals 4x, because this is 4 is the gradient is the m, and then c is the y-intercept, so 4x minus 3. For this one, m is -5, c is 1, and we put that into the equation, gives us y equals minus 5x, and then plus 1. This is where it often becomes more useful to swap it around. I don't love having a negative right at the beginning of an equation, so I would switch that around and I would say that that is 1 minus 5x, because to me, that looks a lot neater. They mean exactly the same thing, they've just wrote it in a different order. And then the last one, the gradient is 7, so that is our m. The y-intercept is 0, so that's our c. So when we write the equation, we have 7x, because 7 is the gradient, and then I'm not even going to write the c, because all I would write is plus 0, and we don't need to write plus 0, because why would you? You're adding on nothing, it doesn't make any difference. So we're just going to leave that as y equals 7x. So I hope that part makes sense. That is how you can tell the gradient and the y-intercept from the equation of the line. I think we're nearly there. Not quite. 2 more things to do. You could be asked to calculate the gradient from a line itself. So here I've got a selection of lines, and I'm going to show you how to calculate the gradient. We calculate gradient by doing, I always say, the change in y, so I'm going to call it m for gradient, is the change in y divided by the change in x. And I just find that that's a nice little, I don't know, it's not like a rhyme or anything, but that just sticks in my head. The words stick in my head because they just kind of flow nicely, I guess. So change in y over change in x. The important part is that you do your y divided by x. To do that, to find the change in y and the change in x, I have a line. I find 2 points on the line, so they could be anywhere. I'm going to choose this one, and I'm going to choose this one. Usually this would be on a graph, so you would choose coordinates. Don't go like in the middle of a coordinate, in the middle of a square, because that's going to make your life really difficult. Choose proper points on a coordinate, and then we're going to join them up with a triangle, like this. Okay? Now, obviously, your up and down is your y, your across is your x. And I'm going to count how many squares I have in both of them. So for the y, I have 1, 2, 3, 4 squares. So my change in y is 4. My x, I have 1, 2, 3, 4 squares as well. So my change in x is 4. So to calculate the gradient, I am going to do the change in y, which is 4, divided by the change in x, which is also 4. 4 divided by 4 is 1. So the gradient of that line is 1. Okay? You need to be able to calculate the gradient yourself. And this is how you do it. So if we move on to the next line, again, I'm going to choose 2 points on that line and choose those 2. I'm going to connect it up with a triangle. My change in y this time is 1, 2, 3, 4, so it's still 4. My change in x is 1, 2. To find the gradient, I'm going to divide the y by the x, so 4 divided by 2, which gives me 2. Okay? That's how you calculate the gradient. It gets a little bit trickier if your line is going in the opposite direction. Now this one, remember we said if we go back, negative is going this way, positive is going up that way. So this line that we have here is going to have a negative gradient because it's traveling in the negative direction. So I'm going to do the same kind of method, and I'm going to choose 2 points on my line. It's not the best line, that's supposed to be a point. And then let's take, say, this one. Yeah. And then again, I'm going to join it up with a triangle. Oh, that's not what I wanted to do. Join it up with a triangle like that. I'm going to count. Just going to move this out of the way. It's better. I'm going to count the y. So 1, 2, 3, 4, 5, 6 for the y. And then just 1, 2 for the x. So the gradient, what I'm going to remember is that it's negative. Okay, I'm not going to worry about which number I put the negative on. I'm just going to write negative, and then I'm going to do 6 divided by 2. So my answer has to be negative. 6 divided by 2 is 3. So my gradient is negative 3. I just always check that I'm going in the direction that I need to. So negative is always going this way, whereas positive is going in the opposite direction. Okay, last couple. This one is a positive gradient because it's going in the positive direction. If I pick 2 points, I'm going to choose this one and this one, draw in my triangle. My change in y this time is 2 and my change in x is 4. So to find the gradient, I'm going to do, don't swap this around, okay? So just because my y number is smaller than my x number, that doesn't mean I can flip my fraction, my division around. I'm doing 2 divided by 4, which is a half. You can have gradients that are fractions or decimals. We tend to leave them as fractions, but a decimal wouldn't be wrong. So the gradient of this one is 1 over 2 is a half. This one is going to be a negative gradient because it's going in the negative direction. So again, I'm going to choose 2 points and choose these 2. I'm going to connect them up with my triangle. My change in y this time is 2. My change in x is 1, 2, 3, 4, 5, 6. So to find the gradient, because it's negative, I'm going to write the negative there first so I don't forget. And then I'm doing 2 divided by 6, which is negative 1/3 when I've just simplified the fraction. Okay, so again, we can have positive gradients, we can have negative gradients, we can have fractional gradients, we can have negative fraction gradients. But the method is the same each time. We decide whether our answer is going to be positive or negative on how the direction the graph is traveling, and then we draw our triangle on, we divide the y by the x, and that gives us the gradient. Right, finally, we're going to put all that together and we are going to find the equation of a straight line from the graph itself. We are not given any information other than a line drawing on an axis, okay? So starting with the pale blue line, we're going to work out the equation of it, okay? So let's just use that same colour. The first thing I'm going to do is find the gradient. So I'm going to pick 2 points and then draw my triangle on. So I'm going to choose this point. I can't see it. I'm going to choose this point and I'm going to choose this one. I'm going to draw my triangle on. This one is 1, 2, 3, 4. So 4 on the y, 2 on the x, which means my gradient is 4 divided by 2, which is 2. So now I've got the gradient. I can see where it's crossing the y-axis. It's crossing here at 4. That's positive 4. So I can then put those 2 things together into the equation to find the equation of the line. So it's y equals m is the gradient. My m is 2x plus c. This time c is 4, so plus 4. That is the equation of that line. Okay? I know I'm going through this quite quickly now. It's just because I don't want this video to be like an hour long. But we're just putting everything together that you've learned so far. So we know how to find the gradient. We know what the equation of the line should look like. We know we need to find out the gradient and the y-intercept to be able to write the equation of the line. For the next line, for the pink one, again, I'm going to find the gradient first. I'm going to pick 2 points to make finding the gradient easier. So I'm going to pick this one and I'm going to pick this one all the way over here. I'm going to draw the triangle in. I didn't say this before, but I should have. It doesn't matter how big or small your triangle is. You could draw a triangle of a different size, but as long as you divide it properly, you're still going to get the same answer that I get with my triangle for the gradient. So this time, my y value is 2, my x value is 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that right? No, it's not. My y's 3, not 2. Oh, that's too big. This is actually 3. 1, 2, 3. Yeah, that's 3, and this is 9. So my gradient, I'm doing the y, which is 3, divided by 9, which gives me a third. It's crossing the y-axis at -3. So when I put that into the equation, I get y equals. So the gradient is a third. So a third x, a third is the m, and then minus 3 because it's crossing the y-axis at -3. And then very last one, we've got this dark blue line. I'm going to pick 2 points to find the gradients. I'm going to pick those 2. I'm going to join it up. I can see that my gradient is going to be negative. So I'm going to do m equals, this is 2, this is 2. So minus 2 divided by 2, which is just minus 1. Because 2 divided by 2 is 1. That's my gradient. It is crossing the y-axis up here at 8. So the equation of the line is y equals minus x. I don't need to write the 1. I could. If you write minus 1x, that's still correct. We just don't need the 1. So minus x plus 8, because that's where it's crossing the y-axis. So a bit of a whistle-stop tour there of straight line graphs. But obviously go back over the bits that you're not sure of, do some practice, and hopefully this should start to make a bit more sense. It is a difficult topic. There are more bits to add to this, loads of algebraic things that you'll do kind of on higher IGCSE. But for now, we're just going to leave it there with the basic straight line equation things, and then we can build on that in the future. So I hope that helps. I hope it makes sense. Have fun playing around with straight line graphs. Thanks for listening and watching.